Center of gravity is a pretty easy location planning technique. Center of gravity finds the absolute perfect location for a facility to serve other facilities located on the map. In this particular case, let's take a look. That facility is not going to serve all of the other locations equally. Oh, all right, well, back up to the top of the story. While Global anticipates the technicians at the new Itsc, that's IT Support Center, to make a total of 800 depot visit sites annually, these visits will not be evenly distributed among the 5 depots. These are the 5 freight depots of Global Freightways. Global estimates the annual number of technician visits would be distributed as followed. Oh, all right, so some of the depots are going to require more service from the Itsc than others. You can see that Atlanta and Orlando, it looks like it's going to be particularly busy. And the question is posed, now what is the optimal location for the new Itsc? It's now what is the optimal location, because we had actually looked at this before in the previous scenario, but we had picked a location in Wyethville, Virginia, based on the assumption that the Itsc was going to serve each of the 4 airports equally. All right, now in this scenario, we pick back up with the story and we're changing that. We're saying, no. Atlanta and Sanford are going to need like a lot more service from the Itsc. What are we supposed to do? Well, you can actually see if you have the note frame that the formulas are printed. It's still pretty easy. We're just going to take a weighted average. That's what these formulas are here. You say weighted average. How do I calculate a weighted average? Oh, all right. If you are looking for the x-coordinate of the absolute most perfect location, theoretically anyway, for the Itsc, what you do is x-opt, that's what it means, x-optimal, the absolute very best, sigma, sum, q times I. Now q is our usual abbreviation for quantity, but this is the quantity that's being referred to, is the number of visits or trips, the degree of traffic or service, whatever, between the facility you're trying to locate and each one of the destinations. Oh, all right. Now, what's this mean right here? Oh, it's easy. Q, pick a quantity. Well, that's 100. It belongs to Toronto Pearson. Multiply it times the x-coordinate. Okay, 100 is the number of visits for Toronto Pearson, and 2.5 is the x-coordinate for Toronto Pearson. Do that, plus, remember sigma means add up, take that 50, it refers to the number of site visits required by Buffalo, times the actual x-coordinate. This is the weighted part in weighted averages for Buffalo, plus 100 is the number of site visits for Raleigh-Durham, times 5 is the x-coordinate for Raleigh-Durham, plus pair up the number of site visits, 250, times the x-coordinate, well that's 1 for Atlanta, plus the number of site visits here, 300, times the x-coordinate, 3.5. That whole thing is the numerator. In the denominator, be careful. The denominator, we are taking an average of sorts, but it's not the number of depots. Don't divide by 5. It says summation Q. It is sum of the quantities. Some of the quantities add up this column, which you could do, although actually in the case of our particular problem, turns out we really have to do that, because do you notice that they mentioned up here? There's a, right, that is what sum Q is. It's the total amount of, well, in this context, the total number of visits. Anyway, that 800 belongs in the denominator. Oh, all right. So I crunched through that on my calculator. I get 2.8. You say, okay, what is that supposed to mean? Well, just hang on to it. That's the absolute perfect x-coordinate. Now, what's the absolute perfect y-coordinate theoretically for this place? Well, y-opt for the optimal y. It's pretty much the same exercise as up here, except I need to be careful. 100, for instance, for Toronto Pearson, I want to retrieve the y coordinate in the numerator, 18.5, plus 50 visits to Buffalo times 17 is the y coordinate for Buffalo, plus 100 site visits still for RDU times 10.5 is the y coordinate for RDU, plus 250 for Atlanta times 8.5 is the y coordinate, plus 300 visits annually for Orlando Sanford times 4 is the y coordinate. That is all in the numerator. 800 still in the denominator. All right, well, I worked that out, and you can check me on this. I get 8.8. 8.8, that actually is our answer, because it asks what the optimal location is, and I mean, this is just a repeat. Optimal location at 2.8, 8.8. Oh, now that's the answer. I mean, numerically, that's the answer. That is the optimal location for the new Itsc. We do kind of wonder, actually, in reality, where is that? Okay, the 2.8 and 8.8 refer to the original grid that we got these particular coordinates from, and that was, I don't know if you recognize this from the first scenario, my scratch work, that was this grid. Now, if you look up, 2.8 and 8.8, that's really what the star that's pre-printed on this grid was meant to represent. Oh, all right. That's optimal location. Location. Ooh, can't spell location. Location for Itsc. And you see my handwriting from last time where I had said that Wyethville, Virginia was. Oh, actually, this particular image gets you a little insight into how center of gravity works. Right, in oranges was last time, I was working on this problem and I was making the assumption that the 5 airports needed the same amount of service, and that's where we settled on Wyethville, Virginia. Oh, now we say no, Sanford and Atlanta are a lot more busy. We use these formulas, and this is the answer. The answer, if you look like on Google Earth, is that it looks like we're supposed to put the Itsc someplace between Augusta, Georgia, and Columbia, South Carolina. Oh, okay. Why did it change? That's what I indicated up here in green ink. See how center of gravity works? This particular location, we picked it when we thought all of these needed the same amount of service. Then essentially the problem changed because we got more information, and in that information, notice it's Atlanta and Sanford that need more service. They're here and here to the south. They literally, mathematically, pulled the so-called perfect location of the Itsc towards them because they need more service. They took it away from like Toronto and Buffalo. We could locate right there, or it's actually possible, but see, now we're just interpreting. The answer was 2.8, 8.8. Or we could propose that perhaps if there's savings of being at an airport, maybe what they might want to think about is just cheating a little bit and locating this Itsc at the Atlanta airport. See how I'm just sort of fudging it over a little bit? That's assuming that there would be an actual advantage to being co-located at one of the depots.